We're going to make sure our x's and y's are all lined up. Yep, my x's are all lined up, my y's are all lined up. That was a problem on the homework. Bum, bum, bum. You might have got it wrong because you didn't line up your x's and y's. My x's and y's are lined up, so I'm going to write it as the matrix 3, -6, 9, 2, 1, -4. It is an augmented matrix, so I'll put my bar there. The first thing I need to do is I need to locate from left to right which one needs to be 1. That 3 needs to be 1. Easiest way to make 3 1 is go 1/3 times row 1. Becomes my new row 1. You have to have all of this down for points on the test. That's going to make this look like this. We're going to do 1/3 of everything. So we'll do 1, -2, 3, 2, 1, -4. Next thing I have to do is everything in that row needs to become 0. That needs to be 0. So that 2 needs to become a 0. The opposite of 2 is -2. I multiply that by the row that has the 1 in it. So that's row 1. Add it to the row that I'm changing. So that's row 2. It's going to become my new row 2. Continuing on. So we're multiplying everything in row 1 by -2. So -2 times 1 is -2 plus 2 is 0. I should probably write down the first row because we're not changing that. So we have 0. -2 times -2 is +4. 4 plus 1 is 5. -2 times 3 is -6. Minus 4 is -10. Now we go to the next column, and I say what needs to be 1. That 5 needs to be 1. So I'm going to multiply that whole row by 1/5. And it will become my new row 2. My new matrix is, I didn't do anything to row 1. 1/5 of everything in row 2, so this is going to be 1. 10 divided by 5 is 2, so it's -2. And finally, we have to make that last thing 0, so that -2 needs to be 0. The opposite of -2 is a +2 times row 2 plus row 1 is going to be my new row 1. And we are going to have 1, 0, 0, 1, and 2 times row 2, which would be -2 is -4. -4 plus 3 is a -1. So we just have -1, -2. Any questions on any of those steps? You have to know how to do it by hand. Yes, we have calculators, but on the test we'll have problems just like this. They say solve it by hand. If you want to, you can check using your calculator. But I need to see all of this to get any points on it. If I say you have to do it by hand, and you just plug it in your calculator, you get 0 points for it. So if I do not see this work, if you just go from this to the answer, like you have this written down, and then all of a sudden you have this written down, and you don't have all these steps, you get 0 points for it on the test. This problem isn't set up, so I'm checking to see how you use your calculator. I want to check to make sure you can do it by hand. All right, be aware of that. So read directions carefully. Once again, any questions? Yes?
On the test, for the ones that say use a calculator, can we write it out anyway?
Yes. If you have time. Don't waste time. Don't be like, I didn't get the last 2 because I was writing out this giant matrix. Because with a calculator, I could make it 4 variables if I wanted to. All right, so if there's no questions for me, were there questions on the homework? Using calculators? No? Okay, super basic lesson today. The hardest thing we're going to have to do is add numbers together, and simple numbers, I know. We're talking about like -4 plus 7 equaling a +3. This is going to be... I will show you. I will show you how to do that in a second. All right, here's the big takeaway from today's lesson. We are adding and subtracting matrices. In order to add and subtract a matrix, here's the most important part of this lesson, basically. the sizes must be the same. The sizes of the two matrices you're adding or subtracting must be the same exact size. So if one is a 2 by 2, the other one needs to be a 2 by 2. If it's a 3 by 3, the other one's a 3 by 3. If they aren't the same size, then you tell me I can't add them. All right? So if I give you this huge looking problem of adding, and it turns out it's completely different sizes, the extent of that work is just say they're different sizes, I can't add them, Mr. Fabian. Don't be the person on the test that tries to add things that can't be added together. Don't be that person. It's okay, we didn't go over the lesson, you just... You must have to like invent a way to add those. Oh, okay. Nope. We're not going to do that. All right, so the first thing says, find A plus B, given that A and B are those two matrices. So all they're really asking, and the only one I really ask you to have this written down for is this one. You can do it on all of them. I'm going to show every step on this one. So I have negative 4, 3, 5, negative 2, and we are adding that to 7, negative 3, 2, negative 5. It's always good, even if it's a simple problem, to have at least one fully worked out, so when you're studying for the finals and you're stressed out, you can actually see one full example to make sure you have it right. All right, so when I add those two things together, we're going to add every single element in its place. So negative 4 is in row 1, column 1. We are going to add that to row 1, column 1 of the other matrix, so that's 7. So we have negative 4 plus 7. In other words, we're going to add those two things together. Then we'll look at that 3. We are going to add that to that negative 3. So we're going to have 3 plus a negative 3. Keep rolling down. I already used green. Let's use purple. 5 goes with 2. So we'll have 5 plus 2. And finally, I guess yellow, negative 2 goes with negative 5. So we have negative 2 plus a negative 5. So the new matrix, once I add these two things together, is going to become negative 4 plus 7 is 3, 0, 7, negative 7. The thing that allowed me to do that is the fact that these were the same sizes. I believe we can add things, but the quick check is, are they the same sizes? Those are the problems people are going to get wrong. If you haven't already, do the rest of these on this page. All right, if you're on the homework, that's okay. Go back to the assignment so we can all do it together. Make sure we have it correct. This one, am I allowed to add those two things together? Yes, they're the same size. They're the same size. Always do that check. Who's got the answer to this one? Just give me the top row and then the bottom row. Check.
8009.
8009. Do we all concur with that? Cool. Ka-choo. All right. Then we go down to the bottom. A. A says A minus B. Am I allowed to subtract B from A? Am I allowed to? Yes.
Yes.
Because of the same size, right? What'd you come up with?
0, 6, 2.
0, 6, 2. Oh, Kate's shaking her head no. We have to check it now. Because Kate said no. 3 minus 3 is 0. 5 minus a negative 1 is actually plus 1. That gives me 6. 8 minus 6 is 2. Oh, he was right. I don't know why. Wow. All right, C minus D, am I allowed to do that?
Yes.
Yes, Luke, you said yes. What did I come up with an answer for this one? Negative 7, negative 2, 4. So you're saying negative 3 minus 4 is negative 7. 5 minus 7 is negative 2. And 6 minus 2 is 4. I agree. That is correct. C, this is the hardest one to possibly do. Yes. No answer. Not possible. Boom. Different sizes. Whatever you want to put there. Don't do any work because you do work. And I have to take off points if you don't have some kind of thing saying I can't do it. What was that?
My life in a nutshell.
That's your empty set? Your life is the empty set? All right, additive inverse, nothing crazy here. Additive inverse is just when you add the two things together, they equal 0. We're looking for 0 pairs. 2, the additive inverse of 2 is negative 2. Matrices don't make this any harder. So my additive inverse looks like negative a. It is really distributing the negative sign to everything that's in there. It's the opposite of every single element in that matrix. So instead of negative 1, we're going to have a positive 1. A positive 2 turns to a negative 2. 0 stays 0. Boom. 4 turns to a negative 4. Negative 3 turns to a positive 3. 5 turns to a negative 5. Then we have negative 2. We got a 0. And finally we have a positive 9. It actually tells us to do two things in this one. It says find the additive inverse and then add the two things together. So they actually tell you to do a plus negative a equals. Do not put this. Do not just say it equals 0.
But you have to put 0, 0, 0.
Yes, you are right. Exactly. You are basically turning a 3 by 3 matrix into a 1 by 1 matrix and getting rid of your matricey thing. That does not equal 0. It makes every element in your matrix equal 0. Because realistically, we have negative 1 plus 1. That element becomes 0. So the easiest way to do is just count your matrix size. It's a 3 by 3, so we're going to have a 3 by 3 of zeros.
It's like connect 3. That's what I was thinking. It looks like
Connect 3. You mean tic-tac-toe?
Tic-tac-toe would be interesting if you had to drop it, though.
It would be, right?
That'd really
Add a whole new dimension.
I feel like no one would ever win.
Yeah.
Because
I don't think it's just too small either.
no, no one ever. All right. Hey, this got a specific name. It's called a zero matrix. I know, they were really on the ball that day. The very last thing we have to do is scalar multiplication. It is no harder than anything we've done so far. So this lesson is very easy. Scalar multiplication. It means it's scaling every single element in the matrix by some factor. So this scaling, part A, says I'm going to scale matrix A by 3. In other words, 3 times A. You are just going to multiply every element in A with 3. First, I'm going to show a different way to write this. You can also write this as 3 times negative 2, 3, 5. You probably want to have this down in your notes because I can put this on the test, and sometimes it throws people off. It shouldn't, but sometimes this will throw people off versus having the 3 times A. Realistically, we're just distributing to every element in that matrix. So we're going to have 3 times negative 2. We're going to have 3 times 3. And finally, we're going to have 3 times 5. And so that's going to equal a negative 6, 9, and a 15. Even if it's a 2 by 2 or a 3 by 3 or a 100 by 6,000. Yeah, that'd be a big matrix. So we're going to do 4 times this matrix. We are going to once again distribute all of the elements to each element, or the negative 2 to each element. So we're going to have negative 2 times negative 3. We'll have negative 2 times 4. Bloop, bloop. Negative 2 times 2. Negative 2 times negative 6. And our resulting matrix is going to be a positive 6, negative 8, negative 4, and a positive 12. The very last one is just distributing a negative into everything. It is our additive inverse. So we should just switch the signs of everything that's in matrix A. Let's not do all the steps. Let's just go. The opposite is 2, negative 3, negative 5. Whew. That is the entire lesson. That is everything you need for your homework. The hardest 2 problems are probably the first 2 because they're a little bit different than what you did. You got to use your old brain housing group to figure out how to do that one.